Welcome back to Jackson Square. Today we're going to be looking at Teak 6.4c, which says, I can give examples of ratios as multiplicative comparisons of two quantities describing the same attribute. So first we are going to talk about what is a ratio. A ratio shows a relationship between two quantities. So here in our example, we are comparing stars to squares. And it says the ratio of stars to squares is 2 to 5. I want to point out that the order matters. As stars is the first word, then 2, the first number, relates to the stars, and square is the last or second word. 5 relates to squares. So as you can see in our picture, we have 2 stars and we have 5 squares. So stars is talking about, 2 is talking about the stars and 5 is talking about the squares. A different way it can be written is for every 2 stars, there are 5 squares. So remember, the first word and the first number go together, the second word and the second number go together. You can write the ratio of stars to squares in the following 3 ways. So it's very important that we know there are 3 ways in which we can write ratios. We can write them in fractional form, using a colon, or using the word to. In fractional form, our ratio would look like 2 to 5. Notice how I said 2 for the fraction bar, okay? With a colon, it would still be read as 2 to 5, and of course 2 to 5. So these are the 3 ways we would write a ratio: fractional form, with a colon, and with the word to. Next it says, what's the ratio of squares to stars? See, they changed the order. Squares are first and then stars. So our number is going to be different. Write it in 3 different ways. So squares to stars would be 5 to 2, or 5 to 2 with a colon, or 5 to 2 with the word to. Those are the 3 ways we could write it. What is the ratio of all shapes to squares? So when we say all shapes, that means we want to count the total, everything, to squares. Well, we know, write it as a fraction. We know that there are 5 squares. How many total shapes? 5, 6, 7. There would be 7 shapes. So in fractional form, that would be 7 to 5, or 7 out of 5, or 7 over 5, but we're going to say 2, okay? 7 to 5. So now we're going to look at oranges to apples, write it as a fraction. What is the ratio of oranges to apples? So I see 1, 2, 3, 4 oranges and 6 apples, and they told us to write it as a fraction, 4 to 6. When we're writing ratios, you always want to write your ratios in simplest form, okay? Always write them in simplest form. That's very important. If they can be simplified, simplify them. So I see that 4 and 2 are factors of 4 and 6, are factors of 2. So I'm going to simplify this down, and it's going to become 2 to 3. And I can see that physically there are 2 oranges for every 3 apples. 2 oranges for every 3 apples. Okay, so we had 4 to 6, which is the total oranges to the total apples. And then when I simplified it, my ratio becomes 2 to 3. And I can see that there are 2 oranges for every 3 apples. For every 2 oranges, there are 3 apples. We could simplify the ratio to 2 to 3. Okay? Ratios can be compared in 3 ways, just like they can be written in 3 ways. You can compare part to part, apples to oranges. You can compare part to whole, oranges to total fruit. Or you can compare whole to part, total fruit to apples. Okay? So let's see. The important things to remember. One, there are three ways you can write a ratio. The three ways are in fractional form, with a colon, and with the word to. There are also three ways to compare a ratio: part to part to whole, whole to part. We also want to remember to always write ratios in simplest form. Simplify your ratios. Okay? We want to remember that the first word matches the first number. The order matters. So let's go back to our intro, our scavenger hunt, and put some of these to test and see if we did okay. So in our scavenger hunt, it said compare the emoji faces below. Type a numerical statement in each box. So in the boxes, it would have been great if you would have typed it with a colon or with the word to, or if you knew to put it in fractional form. But if you didn't know, it's okay because we're learning. So I just picked out a few of the ratios that I wanted to look at. And we're going to look at big eyes to teeth, tongue to total, and silly face to angry face. So when I say big eyes to teeth, big eyes or any googly looking eyes. So I went through and I counted the big eyes. And for the big eyes to teeth, I ended up with 12 to 9. And that could be simplified. It had a GCF of 3. So 3 goes into 12 4 times, and 3 goes into 9 3 times. So the final comparison is for every 4 big eyes I have, there are 3 teeth. Okay, so 1, 2, 3, 4. So some of the big eyes have teeth. So for every 4 big eyes, there were 3 teeth to match or to compare. Okay, remember, a ratio is comparing two quantities. Next, I want to look to tongue to total. So tongue was anything that I saw the tongue physically sticking out. So when I counted, I only saw 3 tongues. And there's a total of 24 emoji faces. And again, this could be simplified by a GCF of 3. 3 divided by 3 is 1. And 24 divided by 3 is 8. So there was 1 tongue sticking out compared to the 24 total faces, or there was, 1 tongue sticking out for every 8 faces. Okay, 1 tongue for every 8 faces. And then finally, I want to do silly faces to angry faces. So silly faces to me was anything that looked goofy, like this, or these looked goofy to me. So I counted those. The tongue sticking out was silly. I counted those. And angry, I counted angry as anything where the eyebrows were pointed down. Even if they had teeth showing, I counted all of these faces. Angry, I didn't count this as angry. There was a meh face. So when I counted silly faces to angry faces, I counted a total of 12 silly faces to 8 angry faces. Okay? And I see that 12 and 8 have a GCF of 4. So I simplified my ratio and it became 3 to 2. 3 to 2. So for every 3 silly faces, there were 2 angry faces. So I hope that now you understand what a ratio is, how to write the ratio, how to compare the ratio. So let's go practice.